The headquarters of Astra Meridian Developments rose like a shard of polished crystal along the arterial highway cutting through Dubai's financial district. 42 floors of glass and brushed aluminum reflected the desert sun so intensely that passing drivers sometimes shielded their eyes. Inside, the air was cool, precise, and controlled, much like the man whose name was synonymous with the city's skyline. Omar Al-Hadid had spent 32 years shaping steel into ambition. From luxury towers overlooking the marina to award-winning commercial hubs in the business district, his structural signatures were everywhere. Developers trusted him with billion-dollar budgets. Governments consulted him before rewriting urban codes. International journals called him the engineer of certainty. Omar liked that title. Certainty meant safety. Certainty meant control. Certainty meant no surprises. And Omar did not like surprises. It was late 2019, and Astra Meridian was preparing to award the lead engineering contract for its most ambitious development yet, the Skybridge Tower, a 48-story mixed-use skyscraper designed to be the most sustainable high-rise in the region. The building would feature zero-net water systems, solar-integrated facade panels, wind-harvesting architectural fins, a vertical botanical garden spanning 20 floors. It wasn't just another luxury tower. It was meant to symbolize the future. 7 international firms had been shortlisted. 6 were exactly what Omar expected: established European and East Asian engineering conglomerates with decades of high-rise experience. The 7th proposal sat at the bottom of the stack, submitted by a mid-sized engineering consultancy from Southeast Asia. Rivera Structural Innovations, lead engineer, Miguel Rivera. Omar adjusted his glasses and opened the binder. At first, the proposal was impressively organized. Detailed stress models, environmental projections, cost breakdowns. Then Omar reached section 3. He paused, he blinked. He leaned back in his chair. Impossible, he muttered. The proposal recommended integrating engineered bamboo composite lattices into the secondary structural framework of the tower. Bamboo, in a 48-story skyscraper. In Dubai, Omar exhaled slowly, then laughed, sharp and disbelieving. His executive assistant, Layla, glanced up from her tablet. Is something wrong? He wants to use bamboo in a high-rise tower, Omar replied, tapping the page. Bamboo, Layla hesitated. The sustainability metrics in their executive summary were impressive. Impressive on paper, Omar said. So are fairy tales, he flipped further. Claims of tensile strength rivaling structural steel in controlled configurations. Claims of superior flexibility under dynamic load. Claims of carbon-negative life cycle impact within 6 years. Omar closed the binder. File it under non-compliant. Layla didn't move. Sir, the proposal passed the initial compliance review. That's procedural, he said calmly. This is structural reality. He pushed the binder aside. We are building a landmark, not a rainforest experiment. The following afternoon, the selection committee gathered in the executive boardroom. Developers, sustainability consultants, financial analysts, and 2 representatives from the Municipal Planning Authority. Floor-to-ceiling windows overlooked the future construction site, a massive excavation zone waiting to become history. Omar presented his recommendation. A renowned Swiss engineering firm with a traditional reinforced steel and concrete exoskeleton design. Conservative, reliable. Expensive, predictable. A younger committee member, Farid, raised a hand. What about Rivera Structural Innovations? Omar's jaw tightened slightly. Their concept relies on unconventional materials inappropriate for high-rise, load-bearing applications. You mean the bamboo composite? Farid asked. Yes. But their sustainability index is the highest among all submissions. And their cost is 27% lower. Cost is irrelevant if the building underperforms, Omar said evenly. We do not gamble with vertical load transfer. Silence. No one challenged him further. The vote passed. The Swiss firm won. Rivera's proposal was rejected. 3 weeks later, Omar received a message. Subject line, engineer to engineer, 30 minutes. He almost deleted it. Curiosity stopped him. Mr. Al-Hadid, I understand your reservations regarding our hybrid structural proposal. I respect your experience greatly. I am currently in Dubai attending a sustainability symposium. If you are willing to grant me 30 minutes, I would like to demonstrate something practical, not theoretical. No obligation, just data. Miguel Rivera. The tone wasn't defensive. It wasn't aggressive. It was confident. Omar stared at the screen. 30 minutes would change nothing. But certainty welcomed scrutiny. He replied, tomorrow. 3 p.m. 30 minutes only. Miguel Rivera arrived precisely at 2:58 p.m. Early 30s, calm, observant eyes, no arrogance. He carried a compact hard case. Omar gestured to a chair. "You have 30 minutes," Miguel nodded. He opened the case and removed 2 cylindrical samples. 1, structural steel tubing. 2, laminated bamboo composite, treated, pressure-cured, reinforced with resin infusion. He secured the bamboo sample horizontally between 2 clamps fixed to a portable test rig. "May I proceed?" Omar crossed his arms. "Proceed." Miguel attached incremental weights to the free end. 5 kilo down kilo, 15 kilo minimal deflection. He then mounted the steel tube of equivalent mass and dimensions. At 12 key visible bending, Omar leaned forward. "That's controlled lab preparation," he said. "Real-world conditions differ," Miguel nodded. "Correct, which is why we conducted dynamic load simulation tests." He turned on a tablet. The screen displayed 2 digital structural models subjected to simulated seismic stress and wind oscillation. The conventional steel frame showed rigid stress concentration at joint nodes. The hybrid design, steel core with bamboo composite lattice bracing, distributed force more fluidly. Less joint fatigue, reduced harmonic resonance. "Flexibility absorbs energy," Miguel said quietly. "Rigidity transfers it." Omar said nothing. Miguel continued, "We are not replacing steel. We are augmenting it. Bamboo composite bracing reduces overall mass by 14%, which reduces foundation requirements and lateral sway amplitude." He placed printed photographs on the desk. A 15-story hybrid structure in Southeast Asia after surviving a Category 4 typhoon. Adjacent steel-only structure showing joint cracking. Omar studied the images. He had not seen these in the proposal. "Where was this documentation?" Omar asked. "Appendix C through F." Omar remembered stopping around page 22. He had dismissed the rest. For the first time in years, Omar felt something unfamiliar. Not fear, not embarrassment. Uncertainty. The Swiss firm had already begun preliminary modeling. Contracts were signed, but he knew something most committee members did not. The Swiss design's wind load tolerance margin had been tight, within acceptable range but narrow. "What is your design's wind load exceedance margin?" Omar asked. 18% above regional requirement, Miguel replied instantly. Omar's eyes narrowed. 18? Yes. Silence stretched between them. Omar looked at the bamboo sample still holding weight without strain. "Leave the test rig," he said finally. Miguel blinked. "I'm sorry?" "Leave it. I want my team to replicate the data." Miguel smiled faintly. "I was hoping you would. The recalculation." That night Omar did something he rarely did. He stayed at the office past midnight. He reopened Rivera's full proposal, all 126 pages. He read every appendix, every simulation chart, every stress curve, every material treatment specification. It wasn't naive. It wasn't romantic sustainability marketing. It was methodical, precise, engineering. The next morning, he ordered updated wind load simulations on the Swiss design using revised atmospheric data from the previous year's unexpected storm season. Results returned within 24 hours. Wind load exceedance margin -6%. Not catastrophic, but unacceptable. Reinforcement would increase cost by 11% and delay completion by 5 months. Omar leaned back in his chair. For 32 years he had built on certainty. Now certainty required humility. Omar al-Hadid did not sleep much that night. Numbers replaced dreams, wind vectors, load distributions. Stress concentrations, safety margins. For 3 decades, calculations had always confirmed his instincts. This time the calculations challenged them. At 7:10 a.m., he was already in the executive conference room, a black coffee untouched at his side. The city outside shimmered beneath early sun, cranes suspended mid-sky like metal birds frozen in migration. By 8 a.m., the core engineering team had assembled. "Run the simulations again," Omar instructed. "We already have the results," his senior analyst replied cautiously. "Run them again," Omar repeated. They did. The results did not change. The Swiss design's wind load exceedance margin remained negative under revised storm models. Reinforcement would solve it, but at significant cost and delay. Silence settled over the room. One junior engineer finally spoke. "Sir, are we considering alternatives?" Omar stared at the projection screen. For years he had been the alternative to risk. Now risk wore a different face. "Yes," he said quietly, "we are." The emergency board meeting was tense. Investors disliked reversals. Governments disliked uncertainty. Developers disliked embarrassment. Omar stood at the head of the table. "I have new data," he began. He explained the revised wind analysis, the reinforcement requirement, the projected overruns. Then he did something unexpected. "I also have an alternative solution we dismissed prematurely." Several heads lifted. "You're referring to the Southeast Asian proposal?" Farid asked. "Yes." A murmur traveled around the table. "The bamboo design?" another investor said skeptically. "It is not a bamboo building," Omar replied evenly. "It is a hybrid steel core system reinforced with engineered composite lattice." "Is it safe?" the municipal official asked. Omar paused. The answer required more than math. It required admission. It exceeds regulatory safety margins by 18% under updated wind data. The room went still. "That's significantly higher than the Swiss model," Farid said. "Yes." "And you're confident in the material?" "I was not," Omar admitted. "Now I am." Confessions carried weight when spoken by men who rarely made them. One investor leaned forward. "Reopening the contract will cause reputational damage. Building a tower that fails updated wind standards will cause greater damage," Omar replied. Another silence. Finally, the chairman spoke. "What do you propose?" Omar inhaled. "We suspend the Swiss contract pending legal review. We initiate an accelerated reassessment of Rivera structural innovations. We conduct third-party material verification locally. If the data holds, we pivot." "Pivoting on a billion-dirham project?" someone muttered. Omar's gaze did not waver. "We pivot based on evidence." The vote was not unanimous, but it passed. Miguel Rivera answered on the second ring. "This is Miguel Al-Hadid," Omar said. A brief pause. "Yes, Mr. Al-Hadid. The contract is under review." Silence. "And?" Miguel asked carefully. "I need your full structural team in Dubai within 10 days. A long breath traveled through the line. "You're serious?" "I do not reopen contracts lightly." Miguel's voice steadied. "We'll be there." News traveled fast within engineering circles. Some called the decision bold, others called it reckless. An editorial in a regional business journal questioned whether experimental sustainability trends were compromising traditional structural integrity. Omar read the article without emotion. He had faced skepticism before, but this time the skepticism echoed thoughts he himself had once held. At the construction site, foundation work paused. Contractors grumbled, suppliers asked questions. The Swiss firm's legal team requested clarification. Pressure mounted. Omar remained calm outwardly. Inside, uncertainty wrestled with conviction. 10 days later, Miguel walked into Astra Meridian headquarters accompanied by 3 engineers and 2 materials specialists. They brought laminated composite samples, independent tensile test reports, long-term fatigue analysis data, environmental life cycle projections, and certification from international materials laboratories. Omar introduced them to his core team. There was politeness, there was distance, there was scrutiny. For the next 3 weeks, the building became less a project and more a laboratory. Local universities conducted independent tensile strength tests. Wind tunnel simulations were rerun using scaled physical models. Material exposure tests evaluated desert heat, humidity cycles, and UV radiation. Every weakness was probed, every joint connection examined. Miguel remained patient. He answered every question without defensiveness. When one senior Emirati engineer challenged the durability of bamboo composite under extreme heat, Miguel invited him to personally oversee kiln conditioning tests. When a contractor questioned fire resistance, Miguel presented flame spread certification data and resin treatment specifications. Slowly, skepticism shifted, not to enthusiasm, but to respect. The decisive moment came during a live wind tunnel simulation at a regional research facility. 2 scale models stood side by side. Model A, conventional reinforced steel. Model B, hybrid steel core with composite lattice bracing. Simulated gust patterns increased gradually. At peak stress conditions, Model A exhibited significant lateral sway and stress concentration at joint nodes. Model B distributed force through the lattice grid. Less joint stress, reduced oscillation amplitude. The room was silent as the data printed. Omar folded his arms, studying the graphs. "Run it again," he said. They did. Results were consistent. The municipal official, who had been most skeptical, leaned toward Omar. "This isn't a gamble." "No," Omar said quietly. "It isn't." The board reconvened one last time. This time the atmosphere felt different. Measured, serious. Evidence lay stacked in thick binders across the polished table. Omar did not oversell. He presented numbers. Margins. Cost reductions. Construction timeline acceleration. Carbon impact projections. Why hasn't this approach been widely adopted? One investor asked. Miguel answered. Because perception lags behind data. The chairman looked at Omar. Your recommendation? Omar held the room's gaze. We move forward with Rivera Structural Innovations as lead structural partner. The vote passed with a stronger majority than before. The contract shifted officially. Construction would resume under a new structural philosophy. Omar and Miguel sat side by side reviewing integration schematics. Steel core columns. Composite lattice bracing. Node connection design. It's not just about materials, Miguel said. It's about how force flows. Omar nodded slowly. For 30 years, he said, I focused on resisting force. Miguel smiled faintly. Sometimes absorbing it works better. Omar allowed himself the smallest smile. You realize, he said, if this fails, it will be my name first in the headlines. Miguel met his gaze steadily. If it fails, it will be mine too. Silence. Then Omar extended his hand. Then we build it correctly. Miguel shook it. Foundation work resumed. Revised structural blueprints were approved. The steel core framework began rising from the desert floor. Then came the lattice integration. Precision mattered. Every composite segment had to align perfectly with steel anchor nodes. Teams worked late into the night under floodlights. Omar spent more time on site than he had in years. He observed Miguel's quiet leadership. No ego, no theatrics, just data-driven decisions. One evening, as the first lattice grid locked into place, Omar stood back and studied it. The structure looked different. Lighter, almost organic, not fragile, alive. Midway through the 12th floor installation, a shipment delay threatened the timeline. Custom composite sections were held at port due to inspection concerns. Investors grew restless, media whispers resurfaced. Experimental project faces early delays. Omar felt the familiar tightening in his chest. He turned to Miguel. Tell me we didn't make a mistake. Miguel didn't answer immediately. Instead, he walked toward the installed lattice framework and struck one of the composite braces lightly with a testing mallet. The sound was solid, resonant, controlled. We made a decision based on evidence, Miguel said finally. Evidence doesn't disappear because of shipping delays. Omar exhaled. For the first time in decades, he wasn't leading alone. As the structure climbed past 20 stories, something subtle changed. Contractors who had once mocked the bamboo tower began praising its lighter installation process. Foundation engineers acknowledged reduced stress transfer. Financial analysts recalculated cost savings from shorter construction cycles. Even the editorial tone in business publications softened. One headline read, Hybrid innovation may redefine Gulf high-rise engineering. Omar clipped the article and left it on Miguel's desk without comment. Miguel found it and smiled. One evening at sunset, Omar stood at the construction platform on the 30th floor. The desert wind moved through the unfinished lattice sections, producing a low, steady hum. The structure flexed almost imperceptibly. Not in weakness, in resilience. He realized something then. For years, he had equated strength with rigidity. Now he understood. Strength could also mean adaptability. The wind did not break the reed because the reed bent. By the time the Skybridge Tower reached its 32nd floor, it had already become the most talked-about construction site in the region. Some called it visionary, others called it irresponsible. Industry forums debated whether hybrid composite structures would become the future, or a cautionary tale. Omar al-Hadid ignored the commentary publicly. Privately, he read every word. Trouble arrived disguised as routine. The Municipal Structural Authority scheduled a mid-construction stress audit, a standard procedure for high-rise developments. But this audit would include something new, a dynamic lateral stress test under simulated extreme wind conditions. If the structure underperformed, construction could be halted. Miguel reviewed the notice twice. They're accelerating the stress threshold, he said quietly. How far? Omar asked. 5% above standard safety margin. Omar folded his arms. That's aggressive. It's political, Miguel replied. Skepticism still lingered in certain government circles. The idea of composite lattice integration in a skyline-defining tower made some officials uneasy. Omar understood. Cities are proud of their silhouettes. Failure would not just damage a building, it would damage trust. 2 days before the inspection, a regional business outlet published an opinion piece. The article quoted unnamed structural experts questioning long-term durability of composite materials in desert climates. Construction workers noticed the cameras gathering outside the perimeter fence. Investors began calling. Omar kept his voice steady in every meeting. "We build on data," he repeated. But late at night, he stood alone in his office, staring at the illuminated model of the tower. 32 years of reputation rested on a material many still associated with scaffolding and furniture. He wondered, not for the first time, if humility and recklessness sometimes looked similar from the outside. The inspection day arrived with unusual wind. By mid-morning, gusts swept sand across the site, rattling temporary barriers. The stress test equipment had been installed over 2 days. Hydraulic actuators positioned strategically to simulate lateral force. Engineers gathered in hard hats and safety vests. Municipal inspectors stood with tablets ready. Miguel adjusted the control settings. Omar stood beside him. "Final calibration?" Omar asked. Miguel nodded. "We're ready." The actuators engaged. The building trembled, not violently, but noticeably. Data streamed across monitors, deflection readings, joint stress metrics, resonance frequency. "Within projected range," one analyst said. The force increased. The structure swayed slightly more. Still controlled, Omar felt the vibration through the steel beneath his boots. He watched the lattice braces flex, subtle, fluid, intentional. "Threshold at 90%, Miguel reported. The inspector signaled for the final increase. Hydraulics roared louder. The tower moved. For a split second, a sharp cracking sound echoed from somewhere above. Every head snapped upward. "Stop the load!" Someone shouted. Miguel cut the actuators. Silence fell, heavy and immediate. Dust drifted in the air. Omar's heart pounded in his ears. "Locate the sound," the inspector ordered. A team rushed toward the 29th floor. Minutes stretched unbearably long. Omar did not speak. Miguel stared at the data feed, scanning for anomalies. Finally, the radio crackled. Minor connection slip at a temporary scaffolding joint. "Not structural," Omar exhaled slowly. The inspector frowned. "Continue." Miguel restarted the load. The final stress level engaged. The building flexed. Numbers stabilized. No structural failure. No joint fractures, no unexpected stress concentration. After 2 tense minutes, Miguel disengaged the system. The lead inspector reviewed the data carefully. Then he looked up. Structure exceeds safety requirement by 16.8%. A murmur rippled across the site. It had passed, not barely, convincingly. The next morning, headlines shifted. Industry publications requested interviews. Investors stopped calling with concern and began calling with curiosity. But for Omar, the most important moment happened quietly that evening. He and Miguel stood alone on the 33rd floor. The city glowed below. "You heard that crack," Omar said. "Yes. For a second I thought that we were wrong." Miguel finished. Omar nodded. Miguel leaned against the steel core column. "Doubt is not weakness," he said. "Ignoring data is." Omar smiled faintly. "You're younger than me," he said. "But you speak like someone who's already failed once." Miguel looked out at the skyline. "We built a smaller hybrid project 5 years ago. First storm season, minor facade panel detachment. Nothing structural. But the media called it a disaster. And we redesigned the attachment system. Data improved. The next season it performed perfectly." Omar studied him. "You didn't quit." Miguel shook his head. "Innovation survives only if the people behind it do." Just as momentum returned, another complication emerged. Supply chain disruptions delayed a major shipment of treated composite braces. International shipping slowdowns threatened to halt progress for 3 weeks. Contractors panicked. 3 weeks meant financial penalties. Investors pressed for temporary steel substitution. Miguel refused. "Substituting materials mid-phase changes load distribution," he explained. "We can't stop construction entirely," Omar said. Miguel thought carefully. "What if we reorganize the sequencing?" "How?" "We accelerate interior core reinforcement while waiting on lattice shipment. Shift manpower inward," Omar considered the idea. "It would require precise recalculation, but it could prevent total delay." "Run the numbers," he said. They did. It worked. Construction continued, slower but not frozen. Another crisis navigated. Weeks passed. The tower reached 40 floors. Workers who once doubted the composite system now praised its lighter handling weight. Installation teams moved faster. Fatigue injuries dropped slightly due to reduced material mass. One veteran contractor approached Omar privately. "Sir, I was wrong about this system." Omar nodded thoughtfully. "So was I," he replied. Near the final weeks before topping out, an unexpected desert windstorm swept through the city, gusts exceeding predicted seasonal averages. Cranes halted operations. Loose materials were secured. Engineers gathered in the monitoring station. The unfinished tower stood exposed. Miguel watched live deflection readings. Omar stood beside him. The wind howled. The building moved. Not rigidly, not erratically. It swayed like something designed to sway. Readings remained within safe dynamic range. No spikes, no distress signals. After 2 hours, the storm passed. The skyline settled back into stillness. Miguel turned toward Omar. "That was better than simulation." Omar allowed himself a rare, unguarded smile. Reality approved the design. At 48 stories, the final structural beam was lifted into place. Workers signed their names along the painted surface before it was secured. A small ceremony gathered engineers, contractors, investors, and municipal officials. Cameras flashed. The chairman spoke about sustainability and innovation. Then he invited Omar to address the team. Omar stepped forward, helmet in hand. "For decades," he began, "I believed experience was the strongest foundation in engineering." He glanced at Miguel. "Experience is important, but it must remain open." He looked back at the tower. "This building stands because we chose evidence over assumption." Applause followed, not loud, but sincere. Later that evening, after most guests had left, Omar and Miguel remained at the site. The tower rose above them, skeletal yet majestic. "When this project began," Omar said, "I almost dismissed you entirely." Miguel smiled. "You gave me 30 minutes. Omar nodded. 30 minutes changed 30 years of certainty. The wind moved gently through the upper lattice sections, producing that same low hum. Omar listened carefully. It no longer sounded unfamiliar. It sounded right. By the time glass panels began sealing the Skybridge Tower's exterior, the narrative around the project had shifted. What had once been described as a gamble was now called a case study. Architecture journals requested exclusive walkthroughs. Sustainability conferences asked for technical papers. Engineering faculties from 3 countries sent formal invitations for guest lectures. But for Omar Al-Hadid, the most critical milestone still lay ahead. Certification. A building could look magnificent. It could perform well during testing. It could attract headlines. But until it passed final structural certification, it was still only potential. While the skyline admired the tower's rising form, the real complexity unfolded inside. The hybrid system required precise alignment between the reinforced steel core, composite lattice bracing, mechanical ducts, elevator shafts, water recycling systems, and vertical garden infrastructure. One miscalculation could create stress imbalances. Miguel and Omar spent long hours in coordination meetings with mechanical and architectural teams. "This node must remain clear," Miguel insisted during one session, pointing to a structural junction. "If we reroute piping through here, we alter stress distribution." An architect protested. "But the visual symmetry..." "Symmetry doesn't matter if the joint fatigues over time," Omar said calmly. There was no longer tension between them, only collaboration. Late one evening, Omar found Miguel alone reviewing long-term creep data for the composite braces. "You don't relax much, do you?" Omar asked. Miguel smiled faintly. "Not before certification." Omar walked closer to the screen. "Do you ever think about what happens if this becomes standard practice?" Miguel hesitated. "Yes. And? It means smaller firms like mine will be judged differently." Omar studied him. "You're not building just a tower." Miguel shook his head. "No, we're building credibility." Omar understood that more deeply than he expected. For decades, credibility had followed him automatically. For Miguel, it had to be earned, publicly, repeatedly, skeptically. Certification week arrived with little ceremony. Government engineers conducted material fatigue sampling, joint torque validation, thermal expansion stress measurement, foundation load transfer verification, fire resistance inspections. Every test had to align with projections. During the thermal expansion assessment, one data series returned slightly outside expected variance. Only by 0.% still, it triggered concern. "If long-term expansion exceeds tolerance," one inspector said, "we require reinforcement." Reinforcement would not only cost money, it would signal doubt. Miguel requested 24 hours to analyze the discrepancy. Omar agreed. That night, they combed through environmental calibration logs. At 2:17 a.m., Miguel spotted it, a sensor calibration error during peak heat simulation. The data spike wasn't structural, it was instrumental. They recalibrated and reran the model. The variance disappeared. When presented with corrected documentation, the inspectors nodded. Acceptable. Omar felt tension leave his shoulders. Not because of approval, but because the solution had come from patience, not panic. 2 days before final approval, a delegation of international investors toured the building. Among them was a senior executive from a European infrastructure fund. He studied the exposed lattice section carefully. "You replaced mass with intelligence," he said. Miguel responded, "We redistributed force rather than resisting it." The executive turned to Omar. "Will you implement this model in future projects?" Omar paused. 3 months ago, he would have said no without hesitation. Now he answered differently, yes. The word felt deliberate and irreversible. The Skybridge Tower's inauguration drew attention far beyond Dubai. The facade shimmered with integrated solar glass. Vertical gardens cascaded between structural frames. Wind fins rotated subtly near the crown, harvesting energy invisibly. 48 stories of calculated risk. Omar stood backstage before the official ribbon cutting. He adjusted his cufflinks, an old habit before public speeches. Miguel approached. "Nervous?" he asked. Omar considered the question. "Yes," he admitted. Miguel nodded. "That's good." Omar raised an eyebrow. "It means you still care." When Omar stepped onto the stage, applause echoed across the plaza. He looked up at the tower, then at the audience. "For over 3 decades," he began, "I believed the strength of a building came from resisting force." He let the sentence settle. "This project taught me that strength can also come from adapting to it." He gestured toward the structure behind him. "This tower stands not because we avoided doubt, but because we confronted it." He paused. "Engineering is not tradition. It is evidence, and evidence evolves." Then he turned slightly toward Miguel. "And sometimes the future arrives in forms we once overlooked." The applause this time was louder. Not for spectacle, but for acknowledgement. Within 6 months, the Skybridge Tower received international recognition for structural innovation and sustainable design. Research papers analyzed its hybrid model. Universities incorporated its data into engineering curricula. Developers from across the Middle East and Asia requested consultations. Rivera Structural Innovations secured multiple regional contracts. Omar's firm partnered with them on 2. But more important than awards or contracts was the shift in conversation. In boardrooms across the region, engineers began asking a new question. Is there a smarter way to distribute force? One evening, months after completion, Omar visited the tower alone. The building had become part of the skyline, familiar, steady. He took the elevator to the top observation deck. Wind moved gently around the structure. He placed his hand against a visible section of the composite lattice, preserved behind glass for educational display. It felt cool, solid, intentional. He remembered the first time he had laughed at the idea. The certainty, the dismissal. He smiled softly. Certainty had built his career. But humility had expanded it. A week later, Omar received a handwritten letter from a young engineering student in the region. "I attended the Skybridge inauguration. I want to specialize in sustainable structural systems because of it. Thank you for proving that innovation can happen here." Omar folded the letter carefully. He realized something profound. The building was no longer just concrete and composite. It was permission. Permission for the next generation to question precedent. Permission to test, permission to adapt. On the tower's 1-year anniversary, Omar and Miguel met for coffee overlooking the skyline. "Do you miss being certain?" Miguel asked lightly. Omar chuckled. "Certainty is comfortable," he said. "But growth is not," Miguel nodded. "The reed bends," he said, "and survives," Omar replied. They watched the wind move across the city. The Skybridge Tower stood among glass and steel giants, different, yet harmonious. Not fragile, not rebellious. Integrated, balanced, proven. In the end, the most important structure built during the Skybridge project wasn't visible from the outside. It was internal. Omar learned that experience is powerful, but incomplete without openness. Miguel learned that innovation requires persistence in the face of doubt. The skyline gained a tower. The industry gained a new model. And 2 engineers gained something rarer than success, respect built on evidence.